Hello everybody, my name is Albert Cabané, PhD candidate at the Polytechnic University of Catalonia, and I'm going to present my research entitled Laboratory and In situ Characterization of Masonry Materials in a Large Historical Industrial Building in Barcelona. The research presents the experimental methodology applied to an extensive campaign carried out in an historical industrial building of Barcelona built in the 19th century. The outline of this presentation is divided in four parts. First, the motivation of this work. Second, the methodology used during the research. Third, the results and discussion of the data obtained will be presented. And finally, the conclusions and future works extracted from the research will be shown. This research has different motivations. The first one is obtain a careful characterization of the material components in existing structures in order to evaluate their strength capacity, combining laboratory and in situ techniques. The second one is expand the knowledge of different minor destructive techniques, cross-checking the in situ value with the laboratory test results. And the last one is the evaluation of the laboratory test carried out on masonry components and masonry specimens, developing non-standard specimen if it's necessary. The methodology applied during the experimental program is divided into two main branches: in situ and laboratory program. The in situ program could be subdivided into two steps. The first one is the use of the minor destructive techniques on lime mortar and clay bricks. These allow preliminary evaluation of the variability of the properties of the large building in order to optimize the sampling extraction. Then, the second one is extraction of small samples for the laboratory testing. The second branch, the laboratory program, is based on the production of different standard and non-standard specimens on which compression tests are carried out. Finally, the combination of laboratory and in situ characterization allow useful cross-checking data to obtain a careful characterization of the material components and the masonry. The in situ experimental characterization was carried out by three different minor destructive techniques. The first one, the pin penetration test, was executed on 6 zones of masonry walls and on 4 zones of mortar plasters in order to evaluate the lime mortars and the clay bricks. The pin penetration test allows to measure the penetration of a 3 mm diameter pin fired perpendicularly using a specific device. This commercial device is commonly used on concrete and cement mortars. However, a previous research developed at UPC showed the use of this tool on low and medium strength lime mortars. The second minor destructive technique was the screw helix pull-out test, executed on the same 6 zones of masonry walls to evaluate the mortar joint and the brick components. This test allows to measure the pull-out maximum force reached by a high-strength steel helical tie. The pull-out force is used to characterize the material tangential stress. This test could be found on previous research developed at UPC, usually executed on mortar joints. The third in situ technique considered was the pull-off test, executed on the same 4 zones of mortar plaster where the first test had been carried out. The pull-off test allows to measure, using a dynamometer, the perpendicular pull-off load applied on a 50 mm diameter metal disc. These pull-off forces evaluate the adhesion strength of the lime mortar plaster on the masonry. The in situ program presents a second step based on the specimen extraction. To start the extraction of the masonry components, it is necessary to break a brick using mechanical tools. The extraction of the bricks and lime mortar joints was carried out manually by using a thin, sharp chisel and a nylon hammer. During the extraction, proper conservation and in situ classification of the samples is essential. The extractions of the core-treated masonry samples were done by horizontal drilling using the dry technology proposed by the previous research developed at UPC. It is important to mark the samples before the extraction to guarantee the correct drilling. At least 3 extractions are necessary for the correct characterization of the masonry, although in this campaign, where it was possible, Up to 5 samples were collected. Once the samples have been extracted, it is necessary to maintain the integrity of the cylinders, avoiding disintegration of the sample components. Finally, on this campaign, timber vault components were characterized too. Destruction of their components have been done from the top of the timber vault. A thin chisel was used to remove all the lime mortar joints around the tile to be extracted, and then a trapezoidal trowel was slowly inserted under the tile and used as a lever. While levering the tile up, the trowel was lightly taped with a nylon hammer, trying to avoid any crack appearance in the tiles. The laboratory experimental characterization was carried on the specimens produced with the extracted masonry components and core-treated masonry samples. The specimens were prepared according to the procedures specified in the European standard. Polishing the load surfaces until a constant thickness of 40 mm was obtained. At least 6 bricks were considered for every extraction zone, and 2 standard specimens for each brick were cut. Further, a second non-standard specimen was considered. The non-standard specimens were obtained from the same bricks as the standard ones. The proposed specimen was a cube with a side measuring 40 mm. For the case of the mortar samples, it was difficult to prepare regular specimens with square dimension of 50 mm side as German standard recommend. This difficulty arises from the low consistency and cohesion of the samples. However, given the large number of samples collected, the analyzed samples have sizes close to the standardized ones. To characterize the core-dried masonry specimens, 2 high-strength mortar caps were casted on the top and bottom, creating 2 flat surfaces. The specimens were tested on 2 stages. The first stage was oriented to study the elastic behavior of the masonry and consisted in the application of 3 loading and unloading cycles. The second stage of the test was aimed to characterize the compressive strength of masonry, testing the cylinders under compression until the maximum load was reached. Finally, a new methodology for testing thin clay tiles was developed. This methodology overcomes the problem arising from their limited thickness on the loading direction. For this purpose, a new assembled specimen by 2 clay tiles was proposed. Testing the assembled specimen instead of the single tile allowed the reduction of the slenderness during the compression test. Next, the results obtained will be presented and analyzed. First, the relationship between the minor destructive techniques and the laboratory values are compared. For this comparison, all the graphics show in depth sizes the compressive strength obtained in the laboratory test. The first row of graphics show the relation with the penetration millimeters obtained during the pin penetration test. The second row shows the relation with the tangential stress obtained with the screw pull-out test. In the relation obtained in this research, we could observe that the in situ evaluation of the mortar strength show a possible trend correlation with experimental laboratory results. However, the evaluation of the bricks do not show enough sensitivity. Another stage of the experimental campaign considered compression tests on non-standard cube specimens. During the testing phases in the laboratory, the failure modes shown by the non-standard specimen were observed. The development failure modes on that specimen showed equally cracks on the 4 exposed faces and didn't show any tensile crack. These failures were compared with the indication in the European standard for satisfactory failures of concrete cubes specimens. Furthermore, this proposed specimen has shown satisfactory coefficients of variation in its strength average, similar to those obtained with the standard specimens. Now, we could see the relationship between the experimental compressive strength obtained on standard and non-standard specimens. This comparison makes it possible to observe that the average compressive strength obtained in the non-standard specimens represents between 44% and 58%. This represents an average relationship of 1.9 between the compressive strength obtained with the standard and the non-standard specimen. The characteristic compressive strength of the masonry has been evaluated from the experimental averages and the empirical equations provided by the Eurocode 6 and the American requirement for masonry structures. As observed in the graphic, Eurocode 6 provides the lowest values, while the American requirement results are higher than the experimental ones. Previous research at UPC provided a good relationship between the empirical and experimental strength for masonry with lime mortars over 2 megapascal strength. This good relationship has not been found in this research developed with low-strength lime mortars. In these cases, masonry samples have a lime mortar compressive strength between 0.3 and 1.3 megapascals. The Young's modulus of masonry has been also analyzed in this campaign. The Eurocode suggests a value of 1000 times the compressive strength, while the American requirement suggests 700 times. This graphic shows that the Young modulus estimated from the standards could be overestimated compared with the experimental ratios ranging between 175 and 759 times. Finally, the results obtained for the 22 assembled tile specimens were satisfactory. These results have been characterized by satisfactory coefficients of variation for historic Hammett fire clay units. These were 20% and 22%, similar with the brick specimens tested in this campaign. Observing the failure mode of the tiles, it was characterized by the debonding of the tile into two parts due to the propagation of the crack throughout the whole thickness of the tile. This means that stresses were developed inside the tile. We are going to present now the conclusions and the future works that we obtained in this research. The in situ minor destructive techniques have provided clear correlation trends in the evaluation of the mortar strength. In particular, and for the case of mortar, the sufficient sensitivity of HPT and PPT tests allow the possibility of relating the results with experimental laboratory values. The in situ minor destructive techniques results for the evaluation of the clay bricks still do not show sufficient sensitivity to the variation of the material strength. More research is necessary in order to improve the application of the HPT and PPT for a more reliable in situ characterization of bricks. Tests on non-standard brick specimens show similar scattering than the standard ones. Moreover, a clear correlation could be found between the compressive strength obtained with the two specimens. However, further investigation should be done to analyze the influence of the specimen's size and shape on the compressive strength. The empirical equations provided by the building codes yielded values that overestimated or underestimated the compressive strength obtained from the extracted cylinders masonry cores. And finally, the laboratory testing on novel types of specimen showed consistent results. In particular, the research proposed a novel methodology for the characterization of the thin tile of timber vaults. Finally, we gratefully acknowledge the financial support through the Project Severus from the Ministry of Science, Innovation and University of the Spanish Government, State Agency of Research, as well as that of the European Regional Development Fund. Thanks for your time.